Hello and welcome everyone. I'm your host Tyler Kern. Thanks so much for joining us today for another fascinating discussion with the experts from Vecna Robotics. Today we're discussing how we can understand the navigation of autonomous mobile robots with Zach Dydek. He's the CTO at Vecna Robotics. Zach, welcome to the show. Thanks so much for joining me.
Yeah, thanks for having me. Good to be here.
Well, it's great to talk to you this morning, Zach, and I'm excited to learn a little bit more about autonomous mobile robots. But before we dive into all of that, just give us an idea of your experience and your background and kind of where you came from and what you do now at Vecna Robotics.
Sure, yeah. Well, I got my undergrad in mechanical engineering at Caltech, and I got my master's and my PhD, also mechanical engineering at MIT. I graduated in 2010 and started at Vecna Robotics just after that. So I've been at Vecna for about 10 years, a little over 10 years now. Had a lot of different roles at Vecna. Was one of the architects for the navigation system, which we're going to get into today, and led the software team for some years, and now I'm the CTO. CTO role is mainly making sure we remain technology leaders in the space, keeping tabs on new developments that are out there, doing our own research, development, sort of advanced development, and making sure that our product stays kind of ahead of the game.
Excellent stuff. Well, so just give us the basics, Zach, for understanding navigation of autonomous mobile robots. You talked about just how you have helped, with the development of the navigation for autonomous mobile robots. Tell us a little bit more about that and give us the basics for what we need to understand about this.
Yeah, absolutely. Autonomous mobile robots, or AMRs, work a little bit differently than the sort of legacy robots that have been in the field for a long time. Those are normally called autonomous guided vehicles or automated guided vehicles, AGVs. Autonomous mobile robots, AMRs, do a little bit more thinking about the world. They understand how the world is connected, the topology of the world, and they reason about how to move through a facility more like a person would. So instead of saying, I'm going to drive forward 82.72 meters and then turn to the right by 37 degrees and then navigate forward by 5 meters, they think more about, okay, how am I going to get to my destination? I know I need to go down these aisles and find this open bay and drop my pallet there. They use their local sensors and onboard computing to make decisions about not just in course terms how to move, but even just what's around them, how to negotiate that space. Other drivers, manual equipment, or other robots coming through, obstacles that might be in the robot's way, all have to be taken into account so that the robot can quickly and efficiently get to where it needs to go.
So when it comes to what you're doing at Vecna, kind of what sets Vecna's robots apart, especially in the AMR area, when it comes to what Vecna has created and this navigation system that you've worked on now for over 10 years, kind of what sets Vecna apart from other robotic manufacturers?
Yeah, it's a good question. I think Vecna is kind of in a very unique position with taking AMR technology. Normally it's applied to these little small bots that roam around, like a Roomba-sized footprint. But we've applied it to larger robots that are capable of lifting pallets and tugging trains, which is important piece of a supply chain. So we've taken all that intelligence and we've modified some things and made it practical for these larger robots. And we've also, like you said, we've just been at it a long time. Some of these challenges are really just engineering challenges, and you can throw engineering effort at them and solve those problems. But other pieces of it just take a lot of time to get right, and maybe more importantly, to find out what doesn't work, and that just takes trial and error sometimes to get something out there in the field and understand why it works, why it doesn't work. And then take that through an iterative process, get it to another site. Those things take time to take place. So yeah, we've been at this for a while, longer than a lot of robotics companies have been around at all. And I think that really puts us in a unique position to solve some of these problems.
So am I right in understanding, Zach, that your robots first started off in like a hospital setting?
Yeah,
And if so, kind
yeah.
of how did that maybe help inform, and what did you learn from that experience? I guess that you've now taken over to more of an industrial side.
Yeah, that's right. Yeah, we kind of come at the problem from a different direction than a lot of the kind of legacy players that have had started in making manual vehicles or the sort of AGV type vehicles, because we came at it from an environment that's much more dynamic and much less structured than the warehouse. Like you said, we were in hospitals. We had robots that were a little bit smaller back then. This was many years ago, and they had to navigate around people, around beds being pushed down the hallways, interact with not just staff there on site, but also completely untrained people. Some people have never seen a robot before, and now this robot is showing up in front of them, and how do you negotiate that scenario? Those are kind of challenges that shaped the way we think about the problem. And when we came into the industrial space, it was after many years of research, getting the platform right, and taking those technologies and applying them to that space. We came in with something a lot more flexible and a lot better, able to handle these sort of dynamic situations that happen all the time in warehouses.
Absolutely. So I know when it comes to autonomous mobile robots that there's a difference between path planning and path following. Can you break down the difference there and kind of explain why it's important to kind of know the difference and where Vecna falls when it comes to path planning versus path following?
Yeah, absolutely. Yeah, it's an important distinction. The way I like to think about it is, both of those terms, they both have the word path in them, right? In both cases, you have a path that you would like to follow, a nominal path. In the case of path following, that's just all you do. You follow the path. If something is in the way of the path, you stop. You wait for someone to help, which is kind of the traditional approach. On the other hand, the path planning is a lot more flexible. A robot that does path planning is typically an AMR. It has enough onboard sensing and onboard computing to be able to make decisions about how to follow that path. It might make sense to leave the path to go around that obstacle, and there's enough space and it's safe to do that. So the robot will allow itself to leave the path and come back to it. And it has to make some pretty complicated decisions to do that. Right? It has to look at the world and understand the world and how things move, and that it has enough space and has enough time to make that maneuver. How's it going to get back to the path later? Those are all things that our robots at Vecna have to consider when we're doing this path planning.
And obviously, you want to, in a dynamic environment like like in a dynamic industrial environment where there are moving pieces and that sort of thing. It's not quite a hospital, right, where there are beds and there are people and nurses and that sort of thing. But it is still an active and dynamic environment, right? So, what's the importance of obstacle avoidance and that sort of thing, especially in those types of environments when if a collision happens or something like that, it can be dangerous and that sort of thing. So it kind of talk me through the importance of that obstacle avoidance and why that matters so much in these dynamic environments.
Yeah, absolutely. It's good. It's a good question, and some of our customers have asked the same question.
Mm-hmm.
This obstacle avoidance feature, it's new and it's cool tech, but they've asked us, is it really important? So we've answered those questions, by putting our robots in their facilities and running through, not just an idealized version of what their warehouse is, but the actual warehouse, with the actual workflows and people involved. And what we found, just anecdotally, in the case of one customer where we did this test, is that 80% of the pallets that we moved, this is a pallet truck, we had at least one instance of needing to avoid some obstacle to continue making progress. So 80% of the time, if we didn't have this feature, we would be stopping, right? So we wouldn't be moving that pallet anymore. We'd be waiting for a person to come and either flip the robot into manual and drive around that thing, or move whatever it was out of the way, tell the robot that they can move on. So by having this obstacle avoidance feature, you're really increasing the efficiency of the system. You're allowing the robot to keep moving more, right? You don't want to be wasting time with this robot with all these sensors and stuff just sitting there on the floor. And you're not involving people in that process. You're letting the people do the things that the people are good at, and you're letting the robot do its work. So yeah, we found it to be vitally important. It can often make the difference between return on investment happening short periods of time, the 1 to 2 years, or longer, 3+ years.
Definitely. And I also wonder, just as a follow-up, just what attitudes have been towards utilizing more AMRs, just especially throughout the past year, where people have looked at having fewer people in a facility and looking at the importance of efficiency, but doing as much as they can with fewer people, kind of in a confined space, right? And so what has, just from your experience, what have the attitudes been towards AMRs, and what kinds of questions are you getting from your clients just about capabilities and that sort of thing as a result of COVID-19 and wanting to protect workers?
Yeah, absolutely. It's at top of mind for a lot of our customers, right? How are we going to deal with these changes? The flexibility that our solution offers, I think, is very attractive. We were able to do a lot of deployments completely remotely during this time, which means we weren't sending a lot of people on site. So we were able to just ship the robots and set them up completely here from our office, get them operating and get value to the customer that way. And I think by incorporating AMRs into a lot of these warehouse workflows, we are able to build a more resilient supply chain that keeps people focused on the things that are high value for people to be doing, things that require that human creativity and ingenuity, and letting the robots do kind of the more mundane tasks of just moving things around the warehouse that take a lot of time for people currently, require a larger staff, which has its own challenges, especially during the COVID time. So yeah, there are a lot of really interesting changes that are happening in the market, and a lot of them are going to stick around, for indefinitely, probably.
Yeah, that's a great point. You talked about not being able to go to and visit facilities kind of throughout this time. What does deployment look like for Vecna Robotics and for these AMRs? What kinds of processes do you need to go through, and how quickly can you get a robot like this up and running?
Yeah, since we were less able to travel, we've been able to do these deployments remotely, even internationally. Basically, it just involves getting the robots physically shipped to the site, getting them on the network is kind of a first critical step, and then we have a set of tools that we use here to access the robots securely, remotely, and teach them everything they need to know about how the facility is laid out. They make maps of the facility, but all that can be done remotely, and the robots take all the knowledge that they have and they share it with other robots in the fleet. So if you have one and you teach it everything it needs to know, you just press a button, and then all the robots in the fleet get that same knowledge. So a lot of deployments happen in a kind of crawl, walk, run sort of way. We'll put in 1 or 2 robots, we'll do this remote deployment, we'll prove out the use case and show that the robots are providing good value, and then adding in new robots is very easy to do, right? They just download that knowledge about the site, and then they're able to immediately start adding value. And like I said, all that can happen remotely. It's just a matter of having the right tools, and that's something that we have been working on luckily even before the pandemic started, so we were able to jump into it fairly quickly during last year.
Well, that's fantastic to hear, just that you were able to make that pivot so quickly. And Zach, as we wrap up our conversation today, just talking about navigation for AMRs and everything that involves, do you have any final thoughts, any conclusions, anything you want to leave our audience with, to make sure that either we cover it today, or just anything that you want to say just in summary of our conversation? So let me turn the floor over to you for any final thoughts.
Yeah, absolutely. I think what I'll what I'll mention again is that AMRs and AGVs are very different in the way they navigate. And it's important to understand those differences, especially if you're considering, having one or both of those types of automation technology in your facility. AGVs typically are just going to follow a line. They're predictable, but they're inflexible. And AMRs think a lot more like your people do. They're able to deal with a lot of those challenges that invariably come up. Right? They're not the exception to the rule. Those exceptions that come up, they happen all the time. Right? They are the rule. So AMRs are able to much more effectively deal with those things, and they use their onboard intelligence to make good decisions about how to move and keep material moving through the facility. So that's where I'll leave it. Thanks for talking about this. This is one of my favorite subjects. I could talk all day about it.
Absolutely. Well, we'll have to have you back on soon to have another discussion about it, because it's absolutely fascinating. And I love getting a chance to hear you explain these topics, because like I said, they're fascinating and really applicable to what's going on in the world today. So Dr. Zach Dydek, thank you again so much for joining us today here on the podcast, and again, sharing your expertise on autonomous mobile robots.
Yeah, absolutely. Thanks for having me.
Absolutely. And everyone, thank you for tuning into this episode of the podcast with Zach Dydek from Vecna Robotics. Of course, make sure to stay tuned for more from Vecna. We'll be back soon. Visit Vecna's website as well to learn more about everything that they're doing in the world of mobile robotics. And stay tuned for more content. But until then, from my guest today, Dr. Zach Dydek, I've been your host, Tyler Kern. Thanks so much for joining us.